Okay. Hello, everyone. I welcome you all again in the live session of this course, Automation in Manufacturing, which is offered by NPTEL under the course code of NOC 22ME133. I am Swarit Anand Singh, a PhD student in the Department of Mechanical Engineering, Indian Institute of Technology, Jodhpur. So I'm a PMRF fellow, and through PMRF TA, NPTEL TA scheme, I got this opportunity to interact with you to solve your problems and queries related to this session, this course. So this is a fifth live session. This session will focus more on the content that are covered in the course during week 5. So I hope you all have gone through the course content of this week. And if you have any query, I'm here to solve all those queries if you have any. So we'll wait for 2 to 3 minutes so that others can join, because people are joining continuously. So after 2 minutes, I will start the session. So before that, if you have any query, you can put in the message box, or you can unmute yourself and we can discuss. So there's a Hidash Nasim is saying, sir, automation is also known as robotics. Okay, yeah, Hidas, robotics is a subset of automation, you can say, right? So it is not a synonym kind of thing. Automation is a bigger domain in which robotics is there, right? So Raju Kadam, you want to say something? Okay. So I hope you guys are enjoying this session and enjoying this course also. You are getting lot of things to learn in a single course, be it from mechanical, the concepts of from mechanical engineering, and the concepts from electrical electronics, and maybe all these things in a single course. So So as you all know, we'll proceed with in a similar pattern as earlier. So this session I will take in three parts. So in first part, I will be interacting with you with the with some quiz questions. So there are multiple choice questions will be there, and I will ask answer from you guys, and we'll discuss if there is any underlying concept in those questions, and we'll solve those questions. And then in second part, I will take the questions that are asked on the discussion forum of the course portal. And in the third section, third part, I will be like will discuss your queries one on one, right? So we'll proceed. We'll conduct this session in this pattern only. Okay, so we have sufficient number of members. Let's start this session. So beginning with the MCQ type questions. So first question is on the screen. So I want the participation from you guys, so that it will be more fruitful session for you, as well as it will be motivating for me to uh, to deliver the lecture and uh, this class, to take this class in more efficient manner. So the first question is on the screen. The question says, in inverting type operational amplifier, the output is connected to the fill in the blanks is there, and then terminal through feedback register. So what is the answer? The options are positive supply, negative supply, inverting, non-inverting. So Hidas is saying negative. T. Sankarlal saying C. Ashish Kumar, you have any query? You have raised your hand. Ashish Kumar. Want to say something?
No, sir, we not.
Okay, okay. Okay, so Raju Kadam C. Others, I want answers from you guys. There is no marking here. Okay, I'm not going to judge you or give you marks for this question, answering this question. So just try to give the answer so that you can also interpret that what you have learned from the course till now. The question I'm repeating: the in inverting type of operational amplifier, the output is connected to the which terminal through feedback register? You want the name of the terminal? Option B, Abhishek Pawar. Okay. So option is C. C is the correct option. Like it is an inverting terminal through feedback register where operational amplifier, the inverting type operational amplifier is connected. So yeah, you can see here. Oh, I'm sorry. There's a mistake, I think, because in inverting type operational amplifier, the output connected to the terminal through feedback register is this negative supply is the answer, because this inverting, yeah. So maybe this is a printing mistake here, maybe, or something like that. This is not a, this is wrong answer. This is correct answer, because this you can see from this is the diagram of operational amplifier. The inverting type this terminal is connected to the negative supply of the this negative terminal of the this, what you can say, operational amplifier, right? So I apologize for the mistake. We'll move to the second question. The second question is again on the op-amp only. The gain of an ideal op-amp is, yes, Hidas Nasim, yes, you are correct. So T Shankar Lal saying B. Okay, yeah. So the option is B only, because you must have gone through this slide. This was the equation that we got like from the solving this circuit. So what is there? The gain is in term of like ratio of V output upon V input, and it was like V input tends to 0, right? So if V input tends to 0, it means this gain will tend, like gain will become infinite. So for an ideal op-amp operational amplifier, the gain is always gain is like infinite. Yes. So now the third question. Third question is on the screen. Yes, it is act as a open circuit, right? So now third question. Third question is on the screen. In which type of filter the low pass and high pass filters are connected in series? So we studied about low pass filter, high pass filter. So in which of the filter given in the options have this low pass and high pass both filter connected in series? Okay, we are saying A, that is band reject filter. Any other option? B, okay, band pass filter. B, band pass filter. Yes. So answer is band pass filter. So in band pass filter, what is there? So this is a, this is what, this is the low pass filter, right? So where the frequency which is having the lower frequency which get filtered out, and here the higher frequency from the threshold get filtered out, and once we connect it into the series, like this and then this low pass and high pass in the series, so we will get a band pass filter. So the frequencies in this band get filtered out, right? sorry, pass out, and others get filter out from the signal. So this is band pass filter where the low pass and high pass filter are connected in the series. Now moving to the fourth question. Fourth question is just a definition kind of thing. The Zener diode is, what is a Zener diode? Is an ordinary PN junction diode operated in reverse bias condition, or an ordinary PN junction diode operated in forward bias condition, or an ordinary NPN junction diode operated in reverse biased condition, or an ordinary NP junction diode operated in forward biased condition. Okay, so most of the people are answering A. Yes, so answer is A only. An ordinary Zener diode is an ordinary PN junction diode operated in reverse biased condition. Now moving to the next question. The question number 5 is on your screen. It says like in pulse width modulation, PWM, the duty cycle is defined as a ratio of. It is ratio of pulse on time to pulse off time, or pulse off time to pulse on time, or pulse off time to pulse time, or pulse on time to total pulse time. Okay, D. T. Sankarlal is saying D. D. Raju, D again. Okay. Yes, so answer is D. So pulse width modulation is the ratio of pulse on time to the total pulse time for a duty cycle. Okay, right. Now moving to the sixth question. The question number 6 is on the screen. It says in a flash ADC. ADC is the analog to digital converter, right? So in flash ADC, for 3 number of output data lines, number of comparators required are. How many number of comparators required for 3 numbers of output data line? B. B is the option. Okay. Abhishek for saying 7. B. Okay. Yes. So answer is 7. So how we have calculated this? So we know that n is a number of, if n is a number of output data lines, so the number of comparators is equal to 2 to the power n minus 1. So when we calculate this, because n is equal to 3 here, okay, so it is given 3. So once we calculate, we will get 7. So answer is 7. Now moving to the next question. Question number 7. Question number 7 says a binary word of 4 bits length is called. If there is a binary word having 4 bits, size of 4 bits, so what we call it? It's a nibble, it's a byte, petal, or octal. Okay, yeah, so everyone is saying nibble. Yeah, so these questions are very simple, and it also shows that you guys are paying attention in the posted lecture and doing the classes. Taking that lecture and seeing the videos and learning from that. So yeah, these are the units and size. So 1 bit is like bit. If we combine 4 bit, it will become nibble. Okay. If we combine 8 bit, it become byte, and then 1024 byte is kilobyte, and then we keep combining 1024 kilobyte to megabyte to gigabyte, and further on. Moving to the next question. Question number 7 is on the screen now. In a microprocessor, the data communication bus is designed to transmit 8-bit words. So it is given like 8-bit words will be transmitted by a microprocessor. So it can handle about how many numbers of values? It is asking how many numbers of value can be handled by a microprocessor, which is designated to transmit 8 bits of word, 8 bits word. The options are 8, 64, 128, or 256. Okay, so most of the people have same answer, option D, 256. Yes, so it is 256. So here, how we have calculated this? like if n is the bit size, then the number of values that microprocessor can handle. So it will be 2 to the power n. So 2 to the power n is equal to 8 here. So if 2 to the power n is, it becomes 256, right? Now moving to the ninth question, next question of the in the session. So question is like, among the following, which device are engineered to handle high voltage and currents? So is it microprocessor, microcontroller, microcomputer, or programmable logic controllers? So this is also known as PLC. So which one of the following device are made for handling high voltage and current? So Raju Kadam is saying A, microprocessor. Do you think microprocessor will be able to handle large amount of like high voltage and current? Can somebody tell me at what voltage this microprocessors are uh, generally work? Anyone? Yes, 5 volt, maybe 2.5 volt or 5 volt only, right? So they are not made for more than this, 5 volt. Okay. So for high voltages and current, we prefer programmable logic controllers, that is PLCs. So PLCs are made for handling a variety of range of voltage and current, right? Moving to the, so before going forward, let's see about the structure of the PLC. Okay, so this is the complete architecture of a PLC. So here there is a microprocessor inside it. Then with it, the input ports are connected, and then output ports are connected. The how PLC looks, you must have seen in the course slide. Okay, so in the lecture, you have seen that how PLCs look like. So this is the architecture only. So it have input ports, output ports, and then this microprocessor is connected with the display devices to display the output and the condition, the things that are going inside this. Then there's a keyboard to provide the input to the microprocessor, right? And then this input ports are connected with the data acquisition system. So data acquisition system is the system that is capturing the data using some sensors. So there may be pressure sensor, temperature sensor, flow meters, load cells, liquid levels, PS sensor, or any other sensors. So through using these sensors, this data acquisition system acquire the data, and then it is connected to the input port. This data goes to the microprocessor. Microprocessor process the data as it is programmed for, okay, or the condition that is already written in this microprocessor, okay, and then after that it proceed to the output port, and at the output port there is a digital to analog converter, so or sunlight valves or maybe some relays, okay, where these the corrective actions or uh, the decisions based on the data, the process data is taken. So moving to the next question, I hope you all have got a better idea about how PLC works and how it looks. So Ashish Kumar is raising his hand. Ashish, you have any query?
No, sir, I can't raise any hand.
Okay. By mistake. Okay, no issue. Uh, okay, so there is a hand button. Okay, raise hand button. So if you are pressing that, so it will get your hand. It shows that you are raising hand and you have any query. No issue. So I hope my voice is breaking, isn't it? Is it fine now? Voice is okay, Abhishek. Okay, thank you for the confirmation. I hope you have got a good idea about this PLC and how the PLC architecture look like, and how this PLC PLCs works, right? Or any question related to this PLC? Okay. So if there is no question, we'll move to the next question. Uh, the question is on the screen now. Here you have to do some calculations. So the hexadecimal representation of 348 decimal number is, right? So don't guess, just try to solve. I will give you time of 2 to 3 minutes. So try to solve this. Like this is a 348 is a decimal number. Okay, as you see, 348 is a decimal number, and we have to convert this to the hexadecimal representation. So how, sir, it is 5C. So there is options of 15C, 51C, 1C5, and 5C1. So among this, the answers are there. 5C dash dash. What is dash? So please calculate it. Any answer? Anyone have got this? Any answer? So I'm giving you 1 more minute to solve this question. It's very simple. If you know the trick, sorry, it's 15C. Okay. So we have one answer. It says like 15C is the, this 15C is the answer. Any other answer anyone is getting? Assis is getting 51C. Okay. Any other? So please solve it. Yes, yes, I will. I will definitely solve it. I'm giving you time so that you guys can try it. Okay, and I will solve. I'm just giving time to solve. The one who is like, maybe some of you have solving this question. Since it is a calculation type question, so I'm giving it some time to you guys. Okay, Abhishek is again saying 15C. Okay, so we got two options here and one is here. 30 more seconds. Any other answer? If you're anyone solving this question? Okay. So let's see first the answer. The answer is 15C. Okay. So how you get this 15C? We'll solve it now. So the value is 348, right? So we have to convert 348 in hexadecimal. So hexadecimal is a base of like 16, right? So what we have to do, we have to divide this 348 by 16. So once you divide this 348 by 16, we'll write the remainder here and the quotient value here. So on dividing 16, on dividing 348 by 16, what is the quotient? Sandeep, please tell me. Okay. So okay, so the quotient is 21 and the remainder is 12, right? So in hexadecimal system, so what is there? So these are the what you can say representation. So from, if the remainder is from 0 to 9, you will write it as like that. Okay. So if it is 0 to 9, you will write like 0, 1, 2, 3 as it is, right? But from 10, you have to write it in a this alphabetic number. So for 10, it is A, then B, C, D, E, F. So for 12, it is C, right? So on the place of 12, we'll write it like it is reminder is 12, but we are replacing it with a C. Okay. Now again we will divide this 21 by 16. So what is the reminder and what is the quotient? 16. 1 is the quotient and what is the reminder? Reminder is 5, right? Okay. Now it is not going to further divide. So what we do, we'll take the number in this order. So we'll write this number first, then this number, then we'll move upward in the ladder. Okay. So the answer will be like 1, 5, and there is a 12. So we'll replace this 12 with C. Okay. So the answer will become 15C. Is there any confusion in this? Is there any
Hello,
confusion?
hello. Sir, can you
Sandeep,
show the table?
what?
Sir, can you show the table again?
Okay, table. Yeah, yeah, I'll show. Okay, so table is here. Just let me clear it. So what we are going to do, we are not only going to convert this 348, the decimal, into the hexa. We'll also convert this this 348 into the binary number. Okay, so just try to solve and just check whether you are getting the answer or not. I will also solve. So with you guys. So in for like conversion of decimal to binary, what is the base? Base is the base value for conversion from decimal to binary is 2, right? Is it right? So what we have to do while convert, like we are converting des, uh, decimal to binary, right? So what we have to do here, we again take decimal number. This is 348, right? We'll divide it by 2. Okay. And again in the similar pattern, we'll write the quotient here and the remainder here. So what is the value? 348 divided by 2. What is the quotient? What is the remainder? I think remainder will be 0 because it is an even number. What is the quotient? Can somebody tell me? Yes. So again, we'll divide it by 2. Again, it is an even number. Quotient, the remainder is 0. What is the quotient? Yes. Now again, we'll divide it by 2. What is the remainder? What is the quotient? Remainder will be 1 because it is not an even number. What is the quotient? It is 43. Again, we'll divide it by 2. What is the remainder? 1. What is the quotient? 21. Right? Again, we'll divide it by 2. What is the remainder? 1. Quotient 10. Parth Pandey, you want to say something? Okay. So we'll divide it further. What will get? 2, 0, 5, then 2, 2, 1, and then 2, 0. Right? So in what order we have to take? We have to take from down to up. Right? So the binary representation of 348 will be like 1. We are taking from here to upside, right? So 1, 0, then 1, 0, then 1, 1, 1, 3 times 1, and then 2 zeros. right? So this is the binary representation of 348. Is there any confusion in this? Is anyone having any confusion in this conversion from decimal to binary number? Okay. Now, okay, so we'll match the answer. Answers are here only. So answer is 10101111. Yeah, it is right. Sir, how it this came? This 15 came. Which 15? This you're talking about 15C, Sandeep Kumar. Okay, so we'll again solve it. Like we have solved it for hexa. Now again we'll solve it. No issue. Okay, so what we have to do? We are going to solve. We are going to convert 348 into 348 is a decimal, and we are going to convert it into hexa, right? So what is the base of hexa? It is 16, right? So for 16, what we have to do? We'll divide 348 by 16. We'll write quotient here, remainder here. So what is the quotient? Sandeep Kumar, can you please solve it? Divide 348 by 16. What is quotient and what is remainder? Okay, so 21 is the quotient and 12 is the remainder, right? Okay. Now again, divide this 16 by 21. What do you get? Quotient 1, remainder 5. Is it? Now it is not further dividable. So what we'll do, we'll move from here to here. Like in this direction, in this order, we'll take the number. So the hexa representation for 348 will look like this: 1, 5, and then 12. So what I said, in hexadecimal representation, if the number goes beyond 10, okay, if the number goes beyond 10, so we'll start the alphabet to alphabet will be assigned to that number. Okay, so referring to this table, so if 10 is A, 11 is B, 12 will be C. So what we'll write? Then 348 in hexa representation will become 15C. Sandeep, is there any further confusion? Okay. Okay. So this was the conversion from decimal to hexa and decimal to binary, right? So now we'll do reverse case. What do we have to do? First of all, just convert this binary number to decimal number. We are going to convert this binary number to decimal number. And how we'll do this, we'll see here. Okay. So first of all, what we'll do, we will write this number as it is 1, 0, 1, 0, 1, 1, 1, 0, 0. Right? Now we will, what is the base of that binary? Was 2, right? So what we'll do, we'll start writing 2 to the power starting from 0 to forward from backside. Okay, so 2 to the power 0, then 2 to the power 1, 2 to the power 2, 3, 4, 5, 6, 7, 8. Okay, we'll multiply this value to this value and then add with the other. Okay, so what will be there? So 2 to the power 8 is what? 2 to the power 8 is what? Answers, please. 256. Okay. 2 to the power, sorry, 256. Now we have to add 2 to the power 7 is 128. And 128 multiplied by 0. 128 multiplied by 0 will be 0. Right? It is 128 multiplied by 0. So it will be 0. Right? Then moving forward, 2 to the power 6, it is 64, multiplied by 1 is 64 only. Then 2 to the power 5, it is there, upside it is 0, so we'll write it 0. Okay. Then 2 to the power 4, it is 16. 2 to the power 3 is 8. 2 to the power 2 is 4. 2 to the power 1 is 2, but multiplying with 0, it will become 0. And 2 to the power 0 is 1, but multiplying with 0, it becomes 0. Okay. Now what we'll do, we'll sum this. Adding all this, 256 plus 64 plus 16 plus 8 plus 4. What is the answer? Three 320, then 336, 336, 340, and 348. Right? So is there any confusion, like how we convert binary to decimal? Anyone? Is there any confusion to anyone that how we are converting this binary to decimal? Okay. So I know some of you may be knowing all this process, but one or two, if we got some wrong answer, it means some of you don't know this process. So that's why I'm spending time here. Okay. So, okay, cool. So now this was the third conversion. Now what we'll do, we will convert this 15C, that is hexa number, to decimal number, right? We're going to convert 15C to some decimal number. How this is, like, answer is already there, 348. So how we'll convert 15C to 348? Again, we have to follow the same procedure. What we'll do, we'll write 15C, right? So on the place of C, while doing the conversion, we'll write 1, 5, and C is for 12. So we'll write 12. Again, we have to give the 6, because base for this hexa is 16. So we'll do like this: 16 to the power 1, 16 to the power 0, 1, and 2. Right? So what is the square of 16? 16 into 16. What is the value? 256. And then multiplied by 1, it is 256 only, right? Now, 16 power 1 is 16. 16 multiplied by 5. What is that? 80. Right? Then 16 to the power 0 is 0. And because 16 to the power 0 means 1. Okay. And 1 multiplied by 12 is 12. Now add it. Are you getting that 348? Is it 348 or not? Okay. So using this process, we convert hexa to the decimal number. Right? So we saw like conversion of decimal to binary, decimal to hexa, then binary to decimal, and hexa to decimal. Now what is there any conversion left you want me to again solve, or is there any confusion in that? Any type of conversion? Binary to hexa, yes. So we'll solve like how to do this conversion, like binary to hexa or hexa to binary, right? How we'll do this? Okay. So one is the simple process. So what people can do, like from binary you can convert to decimal. Okay, from your current knowledge. So from binary you can convert to decimal, and from decimal you can convert to hexa. So this is the process that we have learned already, right? If I don't want to convert this binary to decimal, I don't want to waste my time in conversion of binary to decimal and then going to the hexa. I want the direct route for conversion of binary to hexa. Then how we will proceed? Okay. So will see that route, the conversion of binary to hexa. So what is the number written in the binary is 10101110, right? So what we'll take, what is the process is, like we'll take 4 digit together. So this is the 4 digit, then 1 2 3 4, this is the second 4 digit, and this is the one. Okay, now referring to this table, refer this table and check the values of these. So for 1, the value is already 1. Okay, for 0101, 0101, in this table, what is the representation of hexa for 0101? Is there any?
5.
Yes. So it is here. Like if 101, it means like we can add 10 here, 210 here, 20 here, 20 here, 30 here. Okay. For this removing this confusion, I'm adding this. Okay. We can write this in 4 digits like this. Okay. So this 010 is here on 5. Okay. Now what about 1100? 1100? 1100. Here you can see 1100. So it is C, right? So 15C is the answer. Now, any confusion in this conversion of binary to hexa directly? Is there any confusion? Like how we can convert this binary to hexa? Okay. Now next is we have seen this. Now we want to convert this hexa to binary, right? We want 15C to be converted into binary. How we'll do this? What we have to do? We have to do the reverse process. We have to do the reverse process. Okay. So what we'll do for C representation, what is the value? We'll take from here 1100. For 5, what is the representation value? It is 0101, 0101, 1. And for 1, it is 0001. Okay. So now you get the answer 1010 11100. So this is how we can convert decimal to binary, binary to hexa, hexa to binary, or any conversion in between all these 3 types of numbering system. So is there any confusion? Anyone want any like any conversion to be resolved? No. So you all are now okay with this conversion. So I'm giving you just one question, and I want the answer in like 5 minutes. Okay. So the decimal value is 607. 607. What will be the binary value, and what will be the hexa value for this 607? Please solve. What will be the values for 607? There's a similar question in the assignment also. So that will help you to understand and how to solve this assignment question. what is the answer for 607? What will be the binary number or hexa number for decimal number 607? Do it fast. Give me some answers. It's 2 minutes. No answer is there. You guys solving or not? 607. Question is, we have to convert 607. This is a decimal number to binary and hexa. What is the value in binary and what is the value in hexa? This is a decimal number 607. For binary, again we got two answers. Okay, so I'm not going to solve this because we have already spent so much time here. So I'm going to just write the answer. So 607, the binary representation is 10010 and 11111. So I think answer of Abhishek Pawar is correct. 100101111. Yes. And then hexa representation is 25F. So Abhishek Pawar, your answer is correct. In hexa, Ashish Kumar, your answer is also correct. Who has written wrong answer? So Sandeep and Nagar, please be careful in calculation. Okay. So yeah, so this is all about the conversion. As time is going on, we'll move forward. Now we'll take the questions that are in the on the discussion forum. Okay, the first question is like, what is PCB drive? Question says, I need information of PCB drive in optical encoder. So Rajesh is answering, and I think Rajesh is in the class. Rajesh, you are here?
Yes, sir. Yes, sir. I'm in the class, sir.
Okay.
Sorry, sir, for late coming. So I'm in
Okay, no,
college,
no
sir.
issue, no issue. So as the answer is already posted on the forum, so it says like, printed circuit board PCB has microprocessor and other circuitry required for the receiving and transmission and fulfilling its requirement as expected. As in the video, the case study of measuring the rotation of shaft is happening at that point of time. Okay, so we'll see it in a more detailed way. So first of all, there are two terms, that is PCB drive and its relation with the optical encoders. So what is optical encoder? Optical encoder is like a device which is used to detect detect the signals, okay, and like uh, convert that into some digital form, okay, at some intervals. So that intervals are decided by this blocks, okay. So this is a disk where there are perforations at certain distance. So this disk keeps on rotating. So while rotating, at a point, sometime there will be this perforation will be there, and sometime this solid block will come at a point. Okay, we have placed an LED light which is continuously emitting the light. Okay, so and at another end we have placed a photo sensor or this um, the diode which is sensing this or maybe we can say that receiver for this light. Okay, so because there is a continuous light going falling on this photo sensor, so when this perforation will come, it will pass and the photosensor will detect it. But at another moment, because this is rotating, so at another moment, this solid block will come and it will block the light. So this photosensor will not detect that light at that time. So suppose if we have the binary output, so what will be there? So if light is receiving by the photosensor, suppose, so it will giving 1, and if it is not receiving, it is giving value 0. So it will keeps on giving value 1 and 0 according to the pattern of the rotation, right? So using this pattern, we can calculate the rotational speed of this circular disc. So this disc is connected or mounted on some shaft. So we can say that we can get the speed of this shaft, right? So this is what a optical encoder do, okay, or use for. Now, so this is a actual what you can say 3D representation of an optical encoder in a device form. Okay, so there's this LED LED light. Okay, and then there is a receiver end. Okay, with there that is a photo sensor which is placed beneath it, and in between that these two there is optical encoder. Okay, so there's a plate which is having some perforations and that is mounted on the shaft, right? So when we go on a device level, so it look like this. Okay, so it is like this. So there's a shaft will be placed here. Okay, and the lights are like inside it. There's this what you can say this plate is there which perforation, and the LED light is falling from here to, and it is received at that photo diode, this photo sensor diode. And then when we like complete the structure, so it looks like this. Okay, so this is the optical encoder. Now what is PCB drive is doing here? So this is the PCB, what you can say, the PCB board where all the circuits and the required diodes and sensors are placed. Okay, so this is the PCB that is inside the optical encoder, and on this PCB only this diode, or you can say the circuits are mounted. Okay, so diode is receiving the signal, then it is converting that signal, transmitting that signal to some circuit, and that circuit is giving some output to the transferring this output to some like connected device, maybe it microprocessor or controller or something like that. Okay, so I hope you got your answer, and you are satisfied with the answer, Rajesh. Or is there any
Yes, sir, I am
confusion?
satisfied, sir. Sir, and one more thing, sir.
Huh.
Sorry for saying this and asking this. Sir, could you show the 10 questions, please, today what we happen?
Okay, yeah, sure. So we'll just after discussing this, I will show, right? So you have to
Yes,
wait
sir.
for that. Yeah. So okay, so moving to the next question. Next question is on the screen. He is not in the class, I think, but yeah, we'll take the question. The question says like, is the thermal coefficient and temperature coefficient are same? Okay, so okay, so he got confused with between the term thermal coefficient and temperature coefficient. So these two terms are different and used at different places. Okay, so the answer on the portal is also already written there. So answer says like the thermal coefficient is usually known as coefficient of thermal expansion or thermal expansion coefficient, which indicates how the size of any object will change with the temperature which change the temperature. Uh, okay, so we have read about like thermal expansion of any rod or any wire or metallic materials. Okay, or thermal contraction of any non-metallic or something like that. Okay, so like you can see, so if you have pen, you start giving heat, it starts like contracting. Okay, so that shows like this is because of that thermal expansion or thermal contraction, and that coefficient that is used here for this kind of calculations or is the thermal coefficient or the coefficient of thermal expansion, right? While this temperature coefficient is usually known as the temperature coefficient of resistance, where which indicates the change of electrical resistance of the material with change in the temperature. Okay, so this is a change in the electrical resistance with change in the temperature. So at that point of time, we use this term temperature coefficient. So the formulas are also, although they look similar, but it is different. So like this is change in the length, okay, with respect to the temperature, change in the temperature. So this alpha is the thermal coefficient, right? And here, here another this is also denoted as alpha, but this is like change in temperature with respect to change, like change in resistance because of change in this temperature. So this is known as temperature coefficient of the resistance, right? So moving to the next question, I think, yeah. So these are the only two questions that were posted on the this discussion forum. Rest questions are not very relevant to take. Okay, so okay, I'll show the questions that are discussed today again. Before that, if there is any confusion or question to anyone, you can ask. Is there any question or any issue or any confusion or anything anyone want to ask?
No, sir, there is no questions.
Okay, Rajesh. So I'm just showing the questions. Okay. So the first question was like this. The question says that in inverting type of operational amplifier, the output is connected to the which terminal of the feedback register. Okay. So answer was this, but yeah, it was negative supply. It was a mistake there. Second question was the gain of an ideal op-amp like operational amplifier is. So Rajesh, it will be a quick question for you. Just keep answering. What is the answer for this?
Sir, I didn't go to any other video, sir. First
Okay.
videos I have completed, so
Okay.
I don't know answer well.
No issue. Okay. So its answer is infinite. Then we have discussed. You will see this in the video. Then we have this. The third question was like in which filter this low pass and high pass filter are connected in series. So the answer was band pass filter.
Band pass filters.
Yeah. So we connect this low pass and high pass, so we get band pass. Then there's a definition of Zener diode. So Zener, what is a Zener diode? So Zener diode is an ordinary PN junction diode operated in reverse bias condition. Okay. Then what is the this duty cycle in the pulse width modulation? So it is a pulse on time with respect to total pulse time. Then the question was in a flash ADC, that analog to digital converter, for 3 numbers of output data line, number of comparators required are. So we have to calculate it based on the formula, like if n is the number of output data line, so the number of converter comparators are 2 to the power n minus 1. So the value will be 7 because n is equal to 3. Okay. Now it is a very simple question that in a binary word, the 4-bit length is called. So there's a 4-bit, so it is nibble. Okay, so 1 bit is bit, 4-bit is nibble, 8-bit is byte, and then 1024 bytes are kilobyte, and then 1024 kilobyte, megabyte, gigabyte, and terabyte, and so on. The 8th question was again a calculation based. So it was like in a microprocessor, the data communication bus is designed to transmit 8 bits word. It can handle about how much number of values. Okay, so it is calculated on the formula like 2 to the power n, where n is the number of bit size. Okay, so n was 8, so value 2 power 8 is 256. Then the question was like among of the which of the following are engineered for high voltage and high currents. Okay, so all the devices, microprocessor, microcontrollers, microcomputers are designed for low voltages and low currents. Only the PLC is built for that. Then we have discussed about PLC, what is the architecture of PLC and all. The last question we discussed was the hexadecimal representation of 348 decimal number. So what is the hexadecimal representation for this? So answer was this. We have calculated and we have learned about like how this binary to decimal and hexa and interconversion between all these numbers can be done. So we have converted from decimal to binary, from decimal to hexa, then from hexa to binary, then hexa to decimal, and then binary to hexa, and so on. Okay, so all the permutation combination we have seen and we have calculated all these things. So I hope you guys have enjoyed the session and you have learned something from this session. Your concepts are now much clear. If you have any query, if you have any question, you can ask me. Otherwise, we are running out of time. We'll close the session and we'll meet next Saturday again. Yes, Sandeep.
Thank you, sir.
Thank you, sir.
Thank you. Thank you very much. So Rajesh, if you have missed this session, so you can watch that YouTube video that will be uploaded. Okay.
Yes,
So,
sir. Yes, sir.
yeah,
I will
it is
do it,
there.
sir.
Yeah, it is there in the YouTube only.
Yes, sir. And also, I have missed one more session, sir.
Okay, okay, okay. So last
Okay.
session you
So,
missed. So all the
yes, sir.
videos
Yes,
are
sir.
there on the YouTube link. Okay. So link you must have got the
Yes,
link
sir.
also. I think it is
Okay, sir.
it is in the portal only, right? So
Hmm.
I will post the link again here.
So
Just
coming to college means I doesn't have any time to do this work, sir. So this is the problem of mine. So yesterday class I already told my HOD. He
uh,
didn't permit me to attend this session. So that is the problem.
okay, okay, okay. No issue. So yeah, whenever you get time, you can view the video. So this is a channel. Okay, so where all the videos are there. So although like this link is already shared on the NPTEL portal also, so you can visit and just see if you missed the session like this live session, you can be there. But it is more effective when like if you are live, so that we can discuss. Okay, on the go. While watching this video, this recorded video is always a boring task, right? So being a live class is a different feeling. Okay,
Yes,
so
sir.
is there anything to say? Anyone want to say anything? Rest.
No, sir. I think if I see more videos means I can have a doubt.
Yeah, yeah,
So
yeah, sure, sure. You
so I
can, yeah,
have.
you can anytime post it on the discussion forum, or we'll discuss in this live classes also. Okay.
Yes, sir.
So thank you very much. Thank you all for joining the session. Have a good day. We'll meet next week on the same time in the same session. Yeah.
Yes, sir. Thank you, sir.
Thank you.